Now what we have done is, for this circuit, we have said that we will consider one source, that is we have considered 20 volt source. So we have to remove the 10 volt source. Now how do you remove the other energy sources? See, if I look at the circuit, right now having both the energy sources, which are voltage sources, one is 20 volts and other is 10 volts. I am keeping 20 volts right now and I am going to remove 10 volts source. When I have to remove energy sources, okay, I need to keep two things in mind. That is, first I need to identify if it's a voltage source or if it's a current source. So I'm writing over here voltage source, current source. Okay. Now, if it is a voltage source, as in this case it's 10 volts, you have to short the source. If it's a current source, you have to open circuit it. Okay, keep in mind, when I'm removing the other two sources, or I can have multiple sources, in this case I have just one extra source to be removed, which is my 10 volt source. I can have more sources in the circuits. So you have to identify if the sources to be removed are a voltage source or a current source. If it's a voltage source, you will have to short it. If it's a current source, you open circuit. Now since you 10 volts the voltage source, you will short it, okay, and redraw my circuit. So with this condition I am redrawing my circuit over here. This is 20 volts, this is 5 ohms, this is 7 ohms, this is 2 ohms. Okay, I have shorted my 10 volt source. This is there over here. I have shorted it, fine. Now, with this source present, give the flow of current in the circuit. I have already given the flow of current with this source present in my circuit. Now with this source present in my circuit, I will have to calculate my current in 7 ohms. Okay. Now, if I notice the current in 7 ohms is actually a part of current coming from 5 ohms. See, the current coming in 5 ohms at this junction is dividing into two parts. One part is flowing to 2 ohms, other part is flowing through 7 ohms. So ultimately what I need to do is I have to find the current in my 7 ohms, and if you notice over here, the current in 7 ohms is a part of my current in 5 ohms. So if we try to understand, current in 5 ohms is dividing into current in 2 ohms and the current in 7 ohms. You are interested in the current in 7 ohms. Now since 7 ohms is a part of current 5 ohms, to find 7 ohms I can use current divider rule. Okay, I can use current divider rule. But if I have to apply current divider rule, first I will have to know my current in my 5 ohms resistor. And if you notice, the current in 5 ohms resistor is a current coming from my battery of 20 volts. So if I look at the circuit, the current of flowing my 5 ohms resistor is the same as the total current given by this battery to my circuit. So current in my 5 ohms I will find out using Ohm's law. Okay, now, so let me start by finding the current in 5 ohms. By Ohm's rules, the formula is V by R. V is the voltage which is giving me this current. R is the resistance that is being offered to this current of 5 ohms. Now what value of V do I put? In this case, the voltage that is providing the current in 5 ohms resistor is 20 volts. And what is R? I'll write it as R equivalent over here. This is the resistance of current 5 ohms. Now what I mean by this, if I have a look at the circuit over here, current in 5 ohms is going to divide into two parts. One part is going to flow through 7 ohms, second part is going to flow through 2 ohms. So the current that is going to flow in 5 ohms is just not going to flow in 5 ohms, but it is also going to flow in 7 and 2 ohms. So indirectly, the current flowing in 5 ohms is also influenced by the resistor values of 7 ohms and 2 ohms. So when you are writing the equation for R equivalent over here, you have to consider 7 ohms, 2 ohms along with 5 ohms. Because if you notice, this entire network will contain the current that is flowing in 5 ohms. So you have to consider this entire network of resistances. Once you decide which resistors you are going to put over here, how do I write the equation? To write the equation, okay, first of all, check where is your voltage source. Your voltage source is over here. You are standing over here. Your circuit is lying to your right. So start from last end of where my circuit is lying. So if I check here, I get 7 ohms, I get 2 ohms. How would both of them be connected? If you notice, this is a common point, this is a common point for both, so both of them are in parallel, and that will be in series with 5. So when I'm writing R equivalent, what I will write it as, okay, R equivalent would be 7 in parallel with 2, the entire thing would be in series with 5. So when writing your R equivalent over here, okay, you need to keep two things in mind. One is which resistors to consider. Second is how do you write that equation. So once you have decided which resistors to consider, how we have written the equation is, this is how you have written the equation. So you will solve this equation, whatever value you get, x, you put it over here, 20 divided by x, that answer is y, okay. So y is the current of flowing through your 5 ohms resistor. So you have already found the current in your 5 ohms resistor. Next, you will apply directly a current divider rule to find this current out. Now, say the current in 5 ohms, what value we have assigned as y, okay, we have found out. Now we want to find the current in 7 ohms. Here you are going to use current divider rule. So current in 7 ohms is given by the formula of current divider rule. That is the main current, current in 5 ohms, okay, multiplied by, let us go to the denominator part, sum of the resistances through which this main current is dividing. So your current in 5 ohms, which is coming over here, it is reaching this junction and dividing into 2 ohms and 7 ohms. So you have to put them in the denominator and add them up, okay. After that, in the numerator which resistor you put, there are 2 questions for it, or 2 points to consider. Now your current in 5 ohms is flowing through 2 and flowing through 7. After that, which resistor I put over here? You are finding current in your 7 ohms resistor, okay. So you have to neglect 7 ohms. What is remaining is 2 ohms. You have to put 2 ohms over here. The answer that you get after substituting these values, say Z, is the value of current flowing in your 7 ohms resistor. Now this Z should be given a sign. How to get the sign is, compare this direction with the direction in your original circuit, okay. So if you compare over here, both the directions are the same, fine. So this Z should be plus. If the directions are opposite, so this direction was not matching this direction, then this should have been minus Z. So this plus Z is actually the current in my 7 ohms resistor when only 20 volts is present in my circuit. So if I just mount the circuit on my breadboard, connect a ammeter over here, the current value should be same as this, Z amperes, okay. So this completes the current in my load resistor 7 ohms when I have just one source present in my circuit. Next, again, you have to repeat the procedure to find the current in your 7 ohms with only the second source, that is my 10 volts, that is present.